Hello friends, welcome back to my brand new channel SVS Tech. As you know, it is the third video on our series of videos over cloud computing. In the first video, we demonstrated to you the different approaches that you can take to set up your infrastructure on cloud. In the second video, we introduced you to AKKA framework, which is a wonderful framework for building cloud native applications. In this third video, we'll be extending on our second video to discuss Cqrs, which is an architectural pattern that goes hand in hand with AKKA. Welcome to Introduction to Command Query Responsibility Separation (CQRS). So in today's world, web applications receive thousands of requests per second. For example, Wikipedia receives around 3000 to 7000 requests per second. And if you take an example of an e-commerce website, a lot more time a product will be searched for as compared to the times it will be updated. So it is quite obvious that for a modern application, the load for reading data will be quite higher as compared to load for writing data. Therefore, it is ideal to separate our reads and write into different services to deal with the different non-functional requirement of these two scenarios. So while reading data, we are looking for faster access of data. No one likes to keep waiting while images or colors load on their web page. We are also looking for localized access of data. If our application is serving to clients all over the world, we would like to keep our data in localized data stores for faster access. While writing data, we are looking for properties commonly called as asset properties, which are atomicity. All changes to data are performed as if they are a single operation. Consistency. Data is in a consistent state when a transaction starts and when it ends. Isolation. The intermediate state of a transaction is invisible to other transactions. Durability. After a transaction is successfully completed, changes to data persist and are not undone even in the event of system failure. So the architectural pattern for separating the reading and writing mechanism is called CQRS. CQRS involves splitting the application into two parts, the command side and the query side. The command side orders the system to change the state, and the query side gets the information without changing the state. So with CQRS, we can have different services for commands and queries. The command affects the state of an entity, and the query fetches the state of an entity. So as you can see in this diagram, a single model is responsible for both updating the state to the database as well as for fetching the state from the database. Whereas with CQRS, there are two different models, a command model and a query model. Command model is responsible for updating the state to the database, and query model is responsible for fetching the state from the database. The advantage of this approach is that we can individually tune our read and write services depending upon the load they are facing. For example, for a high read load, we can have 50 instances of a read service and 10 instances of a write service if we feel that's enough for it. Individual upscaling and downscaling is possible, which means we can individually upscale and downscale our read and write services depending upon the current traffic. We can optimize how data is modeled for reads and writes because now we have different services for it. Modeling would help us focus on the attributes of product which are more prominent for the end user. For example, description and title are some prominent attributes when a user is trying to search for a product on an e-commerce website. So one of the disadvantages of this approach is that isolating reads and writes into different services introduces an additional level of complexity into the system. So CQRS is a natural fit for an event sourcing framework like AKKA. So if you would have watched our previous video on AKKA framework, if not, kindly do watch, the link is here in the video. You would have realized that AKKA works on actors and events. Events are published to influence the state of an actor in a distributed environment, and we can rebuild the state of our actors using an immutable event log. So if we apply CQRS pattern to AKKA, we issue commands to influence the state of the actors. Upon receiving these commands, the command service generates events which are appended to the event log, after which they start affecting the state of the actors. As an additional step for CQRS, apart from being added to the event log, these events are also persisted in the database. And using the events persisted in the database, we create a snapshot of the actor state so that less events from the main event log are required to be replayed when we restart our system. So as you can see in this diagram, commands are received by the command service, which in turn generate events which influence the state of our actors. Whereas queries are received by the query service, which in turn generate views on the data which it receives from the command service using a data pump. So a data pump extracts the views from the command side and caches them on the query side. So friends, I hope that with this video you must have got an idea of the architectural principle of CQRS and how it is used in an event sourcing framework like AKKA. So friends, do share your feedback in the comment section, and if you like this video, don't forget to give it a thumbs up and subscribe to my channel for more such video, and also don't forget to hit the bells icon. Till then, it is SPS taking leave from you, so see you next time.